All right, so today we're going to talk about something called quadratic roots. So what are quadratic roots? Well, they are going to be the points, all right, the points at which the parabola, what's a parabola, by the way? Good. So it's the curved line that you get when you graph your quadratic functions. All right, but the quadratic roots are going to be the points at which the parabola intersects the x-axis. All right, so the points at which the parabola intersects the x-axis are going to be your quadratic roots. There's other names for it that you'll also hear, so be familiar with all of them. But if I said solve for the zeros, or solve, or like what are the solutions? Or what are the x-intercepts? Those are all talking about the same thing. So roots, zeros, solutions, x-intercepts, whatever you want to call them, are wherever the graph touches the x-axis. So some examples of what that might look like. That's what we'll fill out next, the number of solutions. Since parabolas either look like this or like this, what's like the most amount of solutions I could have? All right, 2. So here's an example of one of the graphs you might get that has 2 solutions. And I know it has 2 solutions because it crosses the x-axis twice. So where I just drew those dots are my solutions, they're my roots, they're my zeros, they're my x-intercepts. All right, remember the x-axis is that horizontal axis, so this is where we're looking. All right, if it has 1 solution, then how many times do you think that the graph touches the x-axis? Just once. So like here's an example of what that might look like. So if it's just 1 solution, that means it has to be the vertex that's touching the x-axis, because that's why there's only 1 value. All right, it could also be negative. Just here's an example of it only touching the x-axis once. If it's no solution, how many times does the parabola touch the x-axis? 0 times, right? No times does it touch the x-axis. So here is an example of what that might look like. Since the x-axis is that horizontal axis, and it doesn't touch it at all, that's why there's no solution, if it looks like that. All right, any questions about the vocabulary? All right, so now we're going to do some examples, and it says find the solutions of the following quadratic equations by graphing. Now, we've done graphing extensively in here. We've done it both by hand and by using Desmos. So today we're going to use Desmos. Yes? All right, so if you haven't already, have Desmos out, because it'll make your life a lot easier for the graphing portion of this. Because if I use Desmos, what do I have to do to graph this? You just type it in the little box, right? Exactly how it looks. So practice doing that. Practice typing y equals x squared plus 4x minus 5 into your little Desmos box. All right, here's what it would look like. So notice I did type it in exactly how it looked on my paper. And then I just need to now look at this graph and identify my quadratic roots. So where does it cross the x-axis? It crosses it at -5. And what else?
0, 1.
And at 1. So yeah, these are the coordinates for it. We are only concerned with the x values. All right, so like x equals -5 and 1 would be my answer. -5 and 1 are my solutions, my zeros, my roots, whatever you want to call them. Questions about that? So then I would just write on my paper for what are the solutions. And they want your solutions written over here. I would write it as x equals -5, 1 in those curly braces. All right, on your practice, you would have to fill in the table and the graph, but you can also use Desmos to help you with that as well. All right, because remember your vertex will always go in the middle. I can graph it on Desmos and look at where the vertex is. So remember the vertex is either the highest or the lowest point. So on this graph, I'll just hover over the vertex. It's -2, -9. And then I would fill in the rest of my table. All right, my x values would be numbers that are near -2. And then my y value, I could, plug in my x values and solve it. Or, and I haven't shown you this before, but maybe you figured it out. If I go to wherever x equals -5, for example, on my graph, all right, what's my y value at x equals -5? So then I would fill that in my table. What's my y value when x is -4? All right, -5. You see that? So I could fill in my table doing that as well. Right, whatever makes you more comfortable. I'll graph that. I'll graph my points. And then I'll make my U-shaped line. Right? And then my solutions simply are just where it crosses the x-axis. All right, makes sense? Any questions? All right, so take 30 seconds and graph number 2 and 3 using Desmos. So graph number 2 and number 3 using Desmos. And identify your solutions and write them in that spot. All right, so I'll let you try that for a little bit, and then we'll go over them shortly. -3. All right, so when you graph number 3, here's what it looks like. Exactly how it looks on my paper into the little box on Desmos. And how many times does my parabola touch the x-axis? 0 times. So how many solutions do I have? All right, no solution. So to avoid any confusion, whenever it's no solution, just write no solution. All right, don't confuse it with like x equal to 0 or anything, because 0 can be a solution. All right, questions about that? Oops, I almost made that mistake. All right, Don't put your stuff away. We have one more thing to go over. I promise I'll give you enough time to pack up. We just have to talk about what the discriminant is. So on the back side of your paper, of your note paper, we're going to talk about the discriminant, which is really just a fancy way of describing a number that's used to determine the number of solutions. All right, so if you're more visual, more right-brained, you can just type it in on Desmos, look at the graph, and figure out your solutions that way. Well, if you're more left-brained, like you're really good with numbers, you can use this formula, b squared minus 4ac. All right, upperclassmen, that should look familiar. All right, ninth graders, that'll look more familiar as we continue this unit. All right, but I can use this formula. Whatever number I get from it will tell me how many solutions there are. So if the discriminant is greater than 0, then there's 2 solutions. If it's equal to 0, there's 1 solution. And if it's less than 0, there are no solutions. I'll explain more why that is tomorrow, but we'll just do a quick example. Also, if you're wondering where the A, B, and C come from, it comes from your standard form of quadratic equations. So ax squared plus bx plus c. If I can identify A, B, and C, I can plug it into that formula and figure out how many solutions there are that way. So what's my A value? Good, for number 7, my A value is 1. What's my B value? What's my C value? Plug that in and I'll just do it real quick. So my B value is 5. My A value is 1. My C value is 4. So b squared minus 4ac. I enter that in my calculator exactly how it looks. And I get that my discriminant is equal to 9. Since it's equal to 9, what category does it fall into? Is it greater than 0, equal to 0, or less than 0? Greater than, so how many solutions do I have? 2. All right, and that's it. So you could probably do a couple on your practice. There's still 3 whole minutes. But there you go, that's the crash course. Really easy lesson today. Any questions?